Welcome to this presentation on smart armor and sensor suits, recycling paths. As wearable technology advances, it's crucial to understand how we can responsibly manage the end-of-life phase of these high-tech garments. Let's explore the challenges and the solutions. In recent years, wearable technology has expanded far beyond fitness trackers and smartwatches. Sensor-embedded armor and suits are becoming essential tools in defense, industrial safety, emergency response, sports medicine, and healthcare. These garments are engineered to track everything from heart rate and posture to chemical exposure and location. Built with advanced fabrics, energy systems, and communication modules, smart armor is redefining safety and performance. But with such innovation comes a crucial question. What happens when these suits reach the end of their life cycle? Recycling smart armor is far more complicated than recycling a typical electronic device or article of clothing. These suits are designed for durability and integration, not disassembly. Components are often permanently fused, stitched, laminated, or chemically bonded, making separation nearly impossible without specialized tools. Adhesives and protective coatings add to the complexity, frequently contaminating traditional recycling streams. Unlike modular devices, where parts can be unplugged or replaced, sensor suits are one tightly bound system. This not only raises the cost of recycling, but also severely limits its feasibility using conventional methods. Within every smart suit lies a network of intricate electronics, flexible printed circuit boards, antennas, GPS trackers, microcontrollers, and wireless transmitters. These components are not only small and hard to access, they are often embedded deep within protective materials, such as Kevlar or carbon fiber. Many contain valuable resources like copper, gold, and rare earth elements. However, because the circuits are custom designed and miniaturized, they defy standard e-waste processing systems. Recovering usable materials requires both manual expertise and advanced separation technology, something not yet widely available at scale. Battery disposal is one of the most pressing concerns when it comes to smart gear. Many suits rely on embedded lithium-ion or lithium polymer batteries hidden within the fabric or armor to remain flexible or covert. These batteries pose significant fire and chemical risks if mishandled during disposal. They cannot simply be thrown away or removed without training. If punctured or crushed during dismantling, they can ignite or leak harmful substances. For recycling facilities and waste workers, this adds serious safety concerns and requires specialized protocols. The embedded nature of these power sources only magnifies the problem. Security is another major hurdle, especially in sectors like defense, law enforcement, or emergency medical services. Smart suits often store or transmit sensitive data such as biometric logs, GPS tracking, or mission-critical communications. This means that before any part of a suit can be recycled, memory chips and internal storage devices must be securely wiped or destroyed. In many cases, due to data protection regulations or national security concerns, entire suits are incinerated rather than recycled. While this ensures confidentiality, it also results in the complete loss of recoverable materials, presenting a sustainability dilemma. Encouragingly, manufacturers and researchers are beginning to develop solutions. One promising approach is designing sensor suits with modularity in mind. By placing power sources and sensors in easily removable compartments, these suits allow recyclers to extract the most valuable components without damaging the rest. Additionally, some companies are experimenting with biodegradable materials for non-electronic parts, so the textile elements can decompose naturally. Integrating disassembly into the design process is a powerful way to reduce waste, lower costs, and improve environmental outcomes in the long term. Given the hybrid nature of these products, a specialized infrastructure is needed, one that brings together expertise in textiles, electronics, and hazardous waste handling. Licensed recyclers play a central role here, offering the experience and equipment necessary to handle complex dismantling and recovery processes. Regional collection hubs, where smart suits can be assessed, disassembled, and sorted, would streamline this effort. On a broader scale, extended producer responsibility policies can require manufacturers to design with recyclability in mind, ensuring they stay accountable for the entire life cycle of their products. Smart suits are no longer just for elite teams. They're showing up in commercial applications, from workplace safety to remote health monitoring. As these products become more common, the volume of associated waste will rise significantly. That's why public awareness is so important. Clear instructions, designated drop-off locations, and mail-back programs must be promoted to guide consumers toward responsible disposal. With smart garments, throwing it in the trash is not an option. Users need to know where to go, what to do, and why it matters. Currently, the recycling of smart armor and sensor suits lags far behind the pace of innovation. But this gap can be closed with proactive design, intelligent policy, and investments in infrastructure. A circular approach means rethinking the entire product lifecycle, from the materials chosen to how a suit is taken apart, recycled, and reborn as something new. As wearable technology continues to evolve, our systems for managing its end-of-life impact must evolve too. Smart armor demands smart recycling solutions, and the time to build them is now. If you work with sensor-enabled gear or manage smart equipment at scale, we're here to help. Reach us by phone, email, or through our website to learn how we can support your recycling needs. Smart suits protect people. Let's ensure we protect the planet when their job is done.